Hey everyone, this is Big Face from Big Face Robotics, and for the past 3 or 4 months I've been working on my latest robot project, which I'm calling the garden arm. So the garden arm is an automated gardening robot, and when I'm finished, hopefully it'll be able to plant seeds, it'll be able to water the plants as they're growing, and I'll probably be adding some additional functionality like cameras and soil moisture sensors. So a little while ago I did post a video on the first version of this robot, and several design iterations later I've arrived at this model, and I'm going to take you through all of the components of the robot, show you how it works, how I've designed it, and then it'll be time for some testing. I haven't actually tested this robot outside in a real life environment yet, only testing in my workshop. So that should be exciting, so that'll be coming later. So I'll start with the chassis of the robot, and you can see that my design uses a length of tube and a few pieces of wood, and the robot base is actually a 2-wheel design, and this runs on the wood, and there are some support pieces under the robot that run along the tube and keeps the robot upright. So in under the chassis plate there is a continuous rotation servo with a gear, and that's driving another gear that's mounted on the drive shaft, if you can see that, that's connected to the wheels, and these run on a couple of bearings under the chassis. Also under here, I think you can just about see it, is an encoder disc attached to the drive shaft, and an encoder circuit that's detecting the wheel rotation. I also have a limit switch at the rear of the robot, and that is so the robot can drive to its home position. So working up from the chassis, we have the mast of the robot and a 3D printed piece that supports this and stops it from tipping over, and also another piece that the mast slots into there. You may remember from my previous design that this mast was a lot longer and actually had the lift mechanism attached, and I've decided to change that. I've kept this as short as possible, and that is why the whole robot sits up on legs off the ground to make this mast as short as possible. So that's the main chassis design, and I've also got an enclosure mounted on here with some electronics in, which I'll cover in a minute. But the next important part is the rotate mechanism that sits on the mast of the robot, and this is coupled to the mast in here with a couple of small bearings and a shaft that runs through these two to couple them together. And you can see another continuous rotation servo that drives the rotate mechanism. I've also got a potentiometer for position feedback, and that runs on a smaller gear attached to the main drive gear, and this is pinned right through this mast, so this gear is fixed, and the rotate servo and pot move around this fixed gear. So from there you've got the main arm of the robot. I'll come back to what the bottle is attached to the back in a minute. We'll move along to the lift mechanism of the robot. Now if you remember, I said originally I had the lift mechanism on the mast of the robot, and I've changed this design to move this to the end of the robot arm. For a few reasons. One, it means that this whole arm doesn't need to traverse up and down, only the tool head, which I'll cover in a minute. And the one downside is it moves a lot of weight to the end of the robot arm. But I've done some testing and it seems to work okay, so I'll just go through this design. You can see another continuous rotation servo in here. I've got 2 support plates that a rack gear runs through, and this is 3D printed rack gear sections, and they are mounted onto a piece of threaded bar that runs through the middle of them, and the nut either end of this threaded bar tightens together on all of these and keeps them in place. You can see the guides that the rack gear runs through, and this keeps it aligned. You can also see a limit switch attached to the bottom of these guides, and that's to detect the lift up limit. That seems to work quite well. So moving on to the tool head at the moment. I've only got a couple of things mounted to this, but one of them, which I'm quite pleased with, is the seeder attachment, and this is what's going to actually plant the seeds, hopefully. And this is a standard servo driving a drum in this housing, and this drum has a hole into it, and as it turns it will deposit seeds out the bottom of this head here. The other thing to note on the tool head is the, if I can get it in focus, is the sonar sensor, and this is the feedback for lift height. So as the lift drops down, it'll be the sonar that's detecting the ground and positioning the lift. At some point I'd also like to attach a soil moisture sensor to here so that the robot can monitor the moisture levels of the soil. You may also be wondering what this attachment is, and this is the watering head. So I've 3D printed a spray nozzle and attached a length of water pipe. That runs all the way back along the robot and down to the panel under here, which I'll cover in a sec, and that is what's going to supply water to the head. And 3D printed bracket up here so I can position this watering head and try and water the area that is underneath the seeder. And this is quite important because it keeps the maths and the control quite simple. So onto the electronics. You'll see that everything on the robot is wired back to this box, and there is an Arduino Nano inside there, and that is doing the control of all of the servo motors, reading the sensors and things like that, and that's in there. And then this is connected via serial, via USB, down to the main control panel that's living under the robot at the moment. So taking a closer look at the panel under the robot, you can see a Raspberry Pi. I've got some 5-volt regulators in here. I need to come up with a better solution for that, but this is working quite nicely for now. And a relay board. The relay board is driven by the Arduino, so there is actually a connection from the Arduino back down to this relay board, and that drives the water solenoid valve that lives under here as well. So in terms of control, the Raspberry Pi will be sending data up to the Arduino Nano that lives up there, and the Raspberry Pi will be running a web server, so you'll be able to connect to this and send commands to the robot via a web app. For power, the whole robot will run off a 12-volt power supply, and I have a couple of UBECs in here at the moment which are giving me 5-volt power for the servos and for the Raspberry Pi. I could probably get away with one decently spec'd 12-volt to 5-volt power supply, and the solenoid valve is 12 volts as well. So for a minute I'm running this all off a 12-volt battery until I can get a reasonable 12-volt power supply to power this robot. But for now, it works quite nicely for testing. The bottle that's attached to the end of the arm over here, I said I would explain more, and that is simply a counterweight. It was the cheapest, simplest option I could think of to add a bit of weight to the rear of the robot arm, because actually the lift mechanism and all the tooling is quite heavy when mounted 600 or 700 millimeters from the pivot point back above the rotate module, and I needed some counterweight at the rear of the robot to balance this out. So overall the robot design is quite sturdy. There is a little bit of wobble in the whole thing, and that's to be expected because of the way these plates back here are designed. They need to be able to run on this tube with a bit of play, so the robot does have a bit of movement, but it's not too excessive, and I've found I can still position the robot accurately enough for the job it needs to do. So there we go, there's the overview of the robot. You can see there's a lot of 3D printing in this one. I've probably redesigned and reprinted each part at least 3 or 4 times to get to where we are, and I'm very pleased with the result. I've also designed this system in such a way that this could be replicated quite easily by anyone with a 3D printer, and All components are off the shelf, easily obtainable parts, including things like the pipe. So anyone could build this. So I'm going to do a bit more function testing inside. I'll show you how the robot moves, how it can be controlled, and the other thing I haven't tested fully yet is actually the seeding mechanism to make sure that this works and I can deposit a fairly controlled number of seeds repeatably. So that'll be the first test before taking this outdoors and seeing if it performs in the real world. So before moving this outdoors, I'm going to do a bit more function testing of all the movements of the robot and let you see how all that works. And I also want to do a test of the seeder, which we'll come to in a minute. But for now, I'm just going to get the robot moving and show you what it does. So here's the test setup. I'm going to put some seeds into the seeder, and I've been testing with some carrot seeds, and these things are very, very small. If I can just get a couple out, you can see pretty small seeds. And I'm going to load up the seeder in here and see if we can get a few to drop nicely at a time. I want to be able to plant about 2 or 3 of these at a time. Maybe 4. So we'll see if we can get that to work. So there we go, the seeds get loaded into here. I'm going to drive the servo. We're going to see how many seeds drop. This was going to take a bit of trial and error. I think I've tested this previously. It's just dialing in the amount of rotation of this drum to drop a given number of seeds. So let's see what we can do. So there we go, first test. I think that dropped about 8 or 9 seeds, which may be a few too many. Just going to get rid of these for a minute so we can see how many it drops on the next time. See if we can dial this in. There we go. They spread out a little bit, but that was 4 seeds. That's working quite nicely. Only a couple of seeds dropped that time. Let's have another go. So I tried various different numbers there, and you can see that it does drop seeds fairly reliably. Sometimes it drops only a couple, sometimes it's dropping 4 or 5. But as a proof of concept and a design, I think it works reasonably well. So the one downside with this design is you can only load one type of seed at a time into the seeder. But as a proof of concept, this is pretty good. It seems to work quite well, and there's enough to start getting the robot planting some seeds and doing some testing. So I'm really pleased with that. One thing to bear in mind is when you finish with the seeds, you need to empty them all out, and you can do this by driving the servo all the way to its end position, and it should dump a whole bunch of seeds out, like so. And you do this a couple of times, and obviously this can be automated to empty the hopper of seeds fully. Takes a few goes. It does eventually empty out. And there we go. So I've moved the whole setup outside, and I've dug this nice vegetable patch, and I'm going to plant this up this year, but I'm also going to be using it for testing the robot. I've got a water supply hooked up, and as I said, I'm running off the battery over here, and I'm going to be running it through some tests, testing the watering system, and I've marked out a little plot here, and that's going to be for robot plant testing. I'm going to see if I get some seeds in the ground. So there we go, back inside after a successful test, and I'm pretty pleased with how the robot performed actually, considering that was genuinely the first time it's been outside and I've attempted to plant any seeds with it. Few little issues. This wood is not perfectly flat, it's been around for a while and has warped slightly. I've got some knots and things like that in the wood, and that means the robot does occasionally struggle a little bit, but a flatter, less warped piece of wood would help massively there, I think. I was really pleased with the watering head. I haven't tested that at all yet, and that works really, really well. After the first few leaks were resolved, and really pleased about the seeding head. I can actually drop seeds into a hole, and hopefully they will grow. I'm going to leave that little patch alone and see if they do grow. I've planted a few by hand while I was out there. I'll compare how the hand planted ones compare to the robot planted seeds. So on the whole, I'm really, really pleased with this project. Obviously a lot left to do on the software. As I said, I'm manually inputting commands at the moment, and that's the only way I've got to control it, so I'm going to be working hard on that. And the other thing I'm considering, and I've been considering this while building this design of the robot, is some waterproofing. So as you can see, everything's sort of hung under plates and tucked away as much as possible, but I still think if this was put out in any sort of rain, there would be problems. So I'm going to probably make some sort of cover, just a rain deflector that sits over the carriage portion, and then something similar for the lift mechanism and the tool head there, just to deflect any rain that falls and keep it away from the servos and electronics. But there we go, that's it for this video. Thanks for watching, and I'll be back soon with an update.